In this video, we're going to talk about the amplitude of a sinusoidal wave. So we're going to keep exploring transformations of sine and cosine. All right, so here, the difference we're doing is we're putting these numbers in front of sine and cosine. This is actually a transformation type we haven't talked about before. So let's actually look at a demonstration about what's going to happen here. All right, so I have my graph of sine of x. Normally when we're graphing it, we only care about this part. All right, so you would just kind of see this part, and then we know it continues forever after that to create the full wave. All right, so that's our sine wave, but really we just care about this kind of first up and down part. All right, so what happens if I put a number in front of sine? Of course, if that number is 1, I get the same graph back. As I increase this number, watch what happens to my graph. And if I make it 3, look at what my graph. So my original sine graph is in red, and my 3 sine of x is in blue. And you can see the only difference is this wave here, this kind of first wave, instead of reaching up to that height at 1, now the height is up there at 3. And where's that 3 coming from? It's the number in front of sine. Here, instead of reaching a low of -1, it's going to reach a low of -3. All right, so we're just making the waves bigger. I can make up waves really big, all the way up to 5, 10, so on. All right, but you can see the waves aren't moving left and right or anything. They're just getting taller and shorter. And another thing we saw in our normal transformations is if I put a negative in front of my function, it's going to flip it the other way. So if I slide a to the left, I can also make the waves shorter, right? Half. Now they're shorter because it's half is smaller than 1. But as soon as I flip negative signs, now my waves are just going in the opposite direction. So if I have -1 in front of sine, instead of going up, I go down. All right, it's just the opposite. And we've seen this before with just the flip that's happening. And of course, bigger negative values, flip it and make the waves bigger. All right, so that's the kind of thing to know with these numbers in front. They just kind of stretch your graph. The waves get bigger if they're positive. If it's negative, it flips it, and then you can make them bigger or even smaller. All right, so a little dance you can do. But again, the important thing is the waves, kind of where the extreme values happen, aren't changing. It's just how big those extreme values are. All right, so now let's quickly graph this. So if we start off with sine of x, let's not worry about this. Sine of x, the biggest value is 1. The smallest value is -1. And sine is the one that starts at 0 and goes up. So if I go to 3 sine of x, now instead of going up 1, I'm going to go up 3. Instead of going down 1, I'm going to go down 3. So now my graph would look like this. Again, the waves happen in the same place. They're just bigger. And then the last one, -2 sine of x. So they go up 2 and down 2. So I already have those on my graph. The only difference is this negative means the waves go in the opposite direction. All right, so that's the basic idea of how this is going to change my sine graph. And this is called the amplitude of a sinusoidal wave. All it is the height of the wave from the midline. So if I look here, on my original sine graph, this height is 1, and this height is 1. On my 3 sine of x, the height from the midline to the top is 3. This height is also 3. -3, but since I'm saying height, and then this height is 2, and this height is 2. So it tells you how big the waves are, and the only difference, again, if it's negative, the wave is going in the opposite direction. All right, so I'm going to graph -4 cosine of x. All right, well, normal cosine of x looks like this. Again, making sure you're using those tick marks to kind of mark out your important values. -4 cosine of x, so instead of going up to 1, it's going to go down to -4. I probably made these too spread out, but -4. And up to +4. And again, the only difference is this negative is going to flip it. So instead of starting at the top value, I'm going to start at the bottom value. But the wave's going to end at the same place, so it hits the midline at the same place. Then this next point is flipped and higher. Comes back down to the midline at the same place, and then that's flipped and lower. All right. Again, if it was +4 cosine of x, it would look something like this. All right, but -4 flips it across as well. All right, it's really important that you get these values right. when they hit the midline, that doesn't change when you make the waves bigger. Here's one for you to try. You're going to try -2 cosine of x. And I'll show you the answer in 3, 2, 1. And your final answer should look like this. So I drew the original cosine graph in red, -2 cosine graph, I flipped it and made the waves bigger. All right, so the amplitude is just the height of the wave. That's the number that's in front of your trig function. And negative value makes it go in the opposite direction. Basically, when you're labeling, I want to see you label the y-axis correctly. So normally you have 1 and -1. Oops, it's a -1. All right, but now when you change the amplitude, you should increase this number to whatever the amplitude was. So that one we had a 4, we had to go up to 4 and down to -4. So I want to see you label the y-axis to show that the numbers are actually getting bigger when you change the amplitude.